Hello everyone, my name is Enzo and today my presentation is about game theory, how international relations and more can be explained using a simple game. So what is game theory? Game theory is the analysis of strategies for dealing with competitive situations where the outcome of a participant's choice of action depends critically on the actions of other participants. It is widely used in international relations, which is the way in which two or more nations interact with and regard each other, especially in the context of political, economic, or cultural relationships. So for this example, I will include 2 players only. However, this game is played on a global scale with every country or state as a player. Here, both player 1 and player 2 have 2 choices only, to cooperate or defect. If they both cooperate, they arrive at the best outcome for both at a time. If they both defect, they arrive at the worst overall outcome. This game in particular is called the prisoner's dilemma. A secret would be an example of a prisoner's dilemma. So for an example, if Russia is keeping something quiet for the United States, therefore cooperating, and later decides to defect, the US would be at a disadvantage unless they defect as well. This is assuming they both have secrets of each other. So as in the prisoner's dilemma, cooperating and keeping the secret is more beneficial to both sides. But if you tell someone the secret defect and make sure the other person doesn't know, you get a higher payout. A current example was the recent nuclear treaty agreement between the US and Russia. As you may have heard, Russia was accused of not keeping their side of the deal, which meant they were building up their nuclear weapons, which was against the treaty. And so as a result, the US backed out of the treaty and so is no longer in place. So here we have the game. This is the entire board. Our first of all, I just want to say player 1 is on the left. It is color-coded in orange. Player 2 is on the top and color-coded in blue. I color-coded them so you could see who's getting which outcome. So here, as you can see in our first outcome, this is a double cooperate outcome where both sides are not doing anything, they're not telling each other secret, and they're not building up their nuclear weapons. Here we have our player 2 defects. For this example, he's telling the secret and player 1 is not. Here we have where player 1 tells the secret and player 2 does not. While it may seem really stupid, like why is player 2 not telling the secret if he knows player 1 is? Well, the thing with game theory games is that they're both in kind of separate rooms, and so they can't really discuss about what they're going to do, and they don't know the choice of the other player until they choose themselves. So here we have the double defect outcome. Both sides are telling the secret, or in another case, both sides are out of the treaty and building up their nuclear weapons, which is where we are actually right now. So what is the best move to make? The best move to make, as long as you did not both agree to cooperate beforehand, is to defect. This is for a couple of reasons. You get the same amount subtracted from your points as if you cooperated if your opponent defects. Your opponent loses 2 points along with you, and if you get the first move in defect, you have a better chance of getting a higher score. This suggestion works in a one-shot game where you no longer have to interact with your other player in the future. So as you can see, player 2 has a -2 outcome when he cooperates and player 1 defects. But if he had chosen to defect instead, yes, he would have still lost a negative. He would have still lost -2. However, player 1 loses 2 points along with him. So as you can see, it makes a lot more sense to defect. So here we have another game. This one is called Stag Hunt, and it's extremely different. So what differentiates it? Stag Hunt is different from the prisoner's dilemma because cooperation has a larger payout than if one side defects. The best outcome is when both sides cooperate, even greater than the payout if one player defects. The worst outcome is defection, which is double defection, because it gives lowest points for both at once. So why is this game called Stag Hunt? It is a situation in which 2 individuals go out on a hunt. Each can individually choose to hunt a stag or a hare. Each player must choose an outcome without knowing the choice of the other. If an individual hunts a stag, they must have cooperation of their opponent in order to succeed. An individual can get a hare by himself, but a hare is worth less than a stag. So here we have the game. Here's your double cooperate outcome where both sides have decided let's go for a stag and they both get +3 as their payout. Here we have player 1 goes for a stag, player 2 does not. Player 1 gets -2 points because remember he can't catch a stag by himself. Player 2 gets +2 points because he went for a hare instead, which you're able to catch on your own. Here we have the same thing except reversed. Player 1 goes for a hare and player 2 does not. And here we have where both sides go for a hare, and we have the lowest overall outcome. So international trade would be an example of a stag hunt game because it requires everybody to cooperate in order to function. If one state defects, the whole system will collapse. I'm making like one state as an essential state, such as China or the US, which imports and exports a lot of things. So for example, in war, it makes sense to stop trading with the country you're at war with, and this is really the only time anybody should really defect in the stag hunt situation. A current example is the China-US trade war, where both sides are putting import tariffs on each other's products. So here we have a game theory strategy. This one is called Grim Trigger. Grim Trigger is a strategy in which you do not defect until another player does. This strategy works only in games which can go on indefinitely, because if he defects the last round, if it's a one-shot game, you will not have another round to defect on. If one player defects once, you defect continuously for the rest of the game in order to prevent being taken advantage of. This is more commonly used as a strategy for Prisoner's Dilemma rather than Stag Hunt. So last round, player 2 defects and player 1 cooperates. Next round, he would defect continuously, round after round, even if it means ending up at this outcome. So here we have yet another strategy. This one is called tit for tat. This is basically copy the move of your opponent in the last round. For example, if you are cooperating and your opponent suddenly defects, next round you would defect, cooperate until he does, etc. This is somewhat similar to the Grim Trigger strategy, except after your opponent defects, you don't do so for the rest of the game, only the next round. So I'm going to be demonstrating tit for tat in this game. It's called Chicken. We'll talk about it more later, but I decided to introduce it now so you get more familiar with it. So last round, player 2 defects, player 1 cooperates. Assuming that they're both playing by a tit for tat strategy, next round they would end up at this outcome, because last round, player 1 cooperated, player 2 defected. This is the exact opposite of what we just had. So if we both do tit for tat and begin by cooperating, we have an infinite outcome of double cooperate, which is especially useful in Stag Hunt, where you both need to cooperate in order to catch a stag. If we both do tit for tat and begin by defecting, you have an infinite outcome of double defect, which is the worst possible outcome in Chicken and pretty much every other game. If you both do tit for tat, only one of you starts with defect. You have an infinite outcome of defect cooperate in a loop, which means an infinite loop of one player cooperating and the other defecting. That's basically what we saw in the last slide. This is better than both starting with defect, because as long as both players stick to tit for tat, there can be no possible double defect. So here we have an application of game theory to real-world problems. How is game theory used? Game theory is used for a variety of different functions in real-world international relations. It can be used to predict how other states or players will act in the future. It can be sometimes applied to worldwide trade, such as what would happen if one state decided to put a tariff on another's product. And it can be also used in war, such as knowing if a player or state's threat to attack or defect will be true. Knowing good game theory strategies always comes in handy. Since states always want to optimize their payout so they come out on top, knowing how to play and react is always important. So the problem with the one-shot Prisoner's Dilemma is it makes no sense to cooperate, as I have shown before. This is mainly because the opposing player has so much more to gain if they defect, and they will also not have to deal with you in the future, hence the one-shot game. In a real-world scenario, there are really no one-shot games, and it is a fact when the states or players do not know when their game will end in a definite relationship, it is more likely they will cooperate, especially if you know the other prefers Grim Trigger strategy. Defecting in a real-world game can also damage your reputation. If you defect too often, other states may never cooperate again. In the case of the Prisoner's Dilemma, you both lose -2, in which case you might as well have cooperated. So here we have the game called Chicken. Finally, sometimes there will be a game where the costs of defecting are too much for both sides to handle. In most extremes, this would be nuclear war. In this case, at least one of the two players must cooperate in order to minimize losses. This, however, leaves the other side free to defect and gain more points. When you see the opponent has no choice but to cooperate, it makes sense to threaten them into cooperation for the rest of the game in order to defect and safely gain points. Therefore, the Chicken game is a good way to maximize your payout by forcing cooperation upon your opponent. So here we have the board. You've seen this before. As you can see, player 1 would actually rather cooperate when player 2 defects. You can see that in the top right corner where player 2 is defecting, player 1 is cooperating. In the square below that, you see if player 1 had cooperated, he would have lost -5. Sure, player 2 may have as well, but looking at an individual payout, losing 2 points is a lot better than losing 5. So if your state can somehow become the sole provider of a necessary good to another state which is not giving you something necessary, you can make this a game of chicken if you do it right. You know the state you're providing a good to must cooperate in order to keep receiving it, so if they stop giving you X, which you do not need, you can go 100% without it. You stop giving them something necessary. So you can now be sure they'll cooperate regardless if you start increasing the prices of the good you're supplying, which means a greater payout for you. This was done in real life. Russia actually became the sole provider of gas to Ukraine. You need gas in the winter because it gets extremely cold there and you literally cannot survive without it. So they were able to raise their prices against them and also bully them into cooperation. If another state said that Russia did something wrong, they would make Ukraine back them up. So game theory is also important in war to determine the best and worst outcomes of a strategy, and it also helps people studying wars to find out how and why they started. One of the main causes of World War I was that each side wanted the first strike advantage. Back then it was beneficial to be on the attacking side of the war, though this could still be true today. So the mentality was if you attack first, you'll never be able to get that one attack back. So here we have the double defect outcome. This is our war game, by the way. In this outcome, we have where both State 1 and State 2 are defending their countries and nobody's attacking anybody. Here we have where State 2 is attacking State 1. State 2 attacks first, they get the surprise attack and the first strike advantage. Here we have State 1 attacks first, State 2 defends, and State 1 gets the first strike advantage. Here we have where both sides attack each other at the same time, and we end up at whole war. Thanks for watching.